So I'll draw the circuit again, hopefully in about the same place. And that'll be RL, that'll be RE, this will be R2, and this will be R1, 1, and this will be VS. Oh, this will be 0 obviously. So, we'll, let's say we had some numbers. So this was more of an analyse this circuit as opposed to a derive value for a certain, or equation for a certain point. So if we said 10 volts, and we'll make this 1.3 kiloohms, and we'll make this 20k. And we'll make this 80k, and we'll make this 4.7k. So resistances are all in kiloohms, and if you're hoping for a transistor, then 2N3904 will be fine, 2N2222, VC184, ZTX653, any small signal or smallish switching transistor would be fine. So there are lots of ways of attacking this. So you could, if you wanted to, take equation 7, which was VS minus everything for IC, which is 1 over RE brackets VS times R. 2 over R1 plus R2 minus 0.7 close brackets times RL, if you wish. And just sub in the numbers, and out it will spit the quiescent value of VC. So here's the ground, which is what I have as my VC. But if I was to ask, what's VB instead, you'd have to derive some new equation, or stop partway through the analysis, because somewhere along the line we had a couple of equations for VB. I don't propose that you derive it every time, although you could if you wanted to, and if you like a very mathematical approach to things, that would be fine. I, on the other hand, would rather just look at the circuit and write on the things I know, and then apply Ohm's law appropriately. So that's what I'm going to do. But either way will work fine. So we know about this voltage here. We know it's 0.7, and we can work out pretty quickly what the voltage across the base will be. Well, the voltage from the base to ground, across the base to ground. So this will be VB. So if you wanted to write equation out properly, then I'd write VB is equal to 10 volts multiplied by R2. R2 is 20, I'll do it all in kiloohms over 80 plus 20. So this is the value of R2, that's the value of R1, that's the value of R2, that's the value of VS. And this ought to come out to 2 volts. That and that cancel. So we've got 2/10 times 10. That's 8 plus 2 is 10. So 2/10 times 10 is 2 volts. So that's our value for VB. So I mean, that is the equation for VB. And the fact that I didn't derive it along the way is neither here nor there. I've still applied the same equation. It's just whether you formally write them all out or And I can get VE because I had an equation for VE as well, which went along the lines of VE is equal to VB minus VE. Well, I've got this now, which is 2 volts. Oh, I'm sorry, that's not right. VBE should be there. This is 2 volts minus, I'll just take the volts, minus 0.7. So that leaves me with 1.3 volts. So I now know what VE is. It's 1.3 volts. Fine. Well, in that case, I can work out what IE is. I can figure out this current here by applying Ohm's law to RE. So I can say I is I times I is V upon R, which is 1.3 volts divided by 1.3 kiloohms. So if you don't fancy remembering its kiloohms, you can write 1300 if you prefer, but I'm going to write 1.3 and I'm going to remember that it's kiloohms. So this will give me 1 times 10 to the minus 3, so milliamp. So I've got IE is a milliamp. I'll pop that on the diagram. 1 milliamp. Now, I also said earlier that IE was approximately equal to IC. So that means that I know what IC is as well. The reason for that was that IB is equal to 0 as far as we're concerned, which is usually true. So I can just put a line through. As long as we're careful about the HFE of our transistor, it has to be nice and big. As long as we're careful about the current that flows down here, then we're okay. IB has to be a very small fraction of the total current that flows down there for it to be a valid assumption. Right, so we have IC now, and we know what VS is, 10 volts, so we can say, well, if I was interested in what VC was going to be, I'd say it's VS minus IC times, oh wow, well I've got IC, it's milliamp. So in that case, we can say 10 minus 1 milliamp times 4.7 kiloohms, and this will leave us with 10 minus 4.7, which is 5.3. And this is a value for VC then, which is across here. Is 5.3 volts. Okay.